Okay, for today what we're doing, the unit circle, being able to generate it in this 5 minutes is not the biggest skill that you need in math. It's just, I would compare the unit circle to a multiplication table. So like the one on the wall, it's a table of multiplication facts, which you could figure out slowly by doing, 3 plus 3 plus 3 plus 3 a certain number of times. But the multiplication table is meant to be memorized, just like the unit circle. You can figure out a lot of this using triangles and all that business, but you ultimately need to memorize it and use it in larger, more difficult problems. So how we use it, we're going to work on today. So going back to this, the unit circle and what it looks like. The unit circle, any point on the unit circle, it has an x-coordinate and it has a y-coordinate. The y-coordinate is always going to be defined by sine of the angle. So if you look over here, you have a certain angle. In this case, it looks to be maybe 50 degrees-ish. This isn't on any piece of paper right now. But the sine of that angle is going to be the height of the triangle in the unit circle. So if I move at different angles, the height or the sine of that angle is going to change. So it changes at 0 degrees. You don't have much of a triangle. You don't have a triangle. You just have the line going out to 1, 0. What's the height there? It has 0 height, so sine of 0 is 0. Cosine of 0 is the x value. So cosine of 0 is 1, going all the way out there. So maybe we'll stick the sine first. So sine of 45, exactly there, is about 707. We came with the approximation the other day. This is not entirely accurate. But you can see that the height or sine of theta, or the angle, increases until we get to 90 degrees. And then the maximum height, maximum y value in the unit circle is 1. And then the height starts to decrease as the angle continues. But no matter where you are, the y value is always sine, or the other way around. You can think the sine of an angle is the y value at that point. So the sine values are positive in the first and second quadrant, but then when I go to the third quadrant, what happens to the sine values? They're negative. They go down. The height is in the negatives all the way through the third and fourth quadrant, and then it goes back to 0 and goes positive again. So the x-coordinate always decided by cosine. Cosine of an angle is the x-coordinate. So if you notice, the first and fourth quadrant, cosine is positive. See that? Cosine is positive in both of these quadrants. But then in quadrant 2 and 3, cosine is negative. Cosine is 0 here at 90 degrees, and where else? Cosine of 270 is also 0 degrees, or is also 0. So somewhere you need to write down, let's see, that the x-coordinate is going to give you cosine of an angle, gives you the x-coordinate. Or you could look at sine of an angle, and that's your y-coordinate. Write that down somewhere. Any questions so far? So how do we use it exactly? What happens is in math, we have to evaluate sine and cosine and tangent of certain angles. For example, sine of 30. Where is sine of 30? What I would do if I were you, well, what I do myself, whenever I'm trying to evaluate sine and cosine and other trig values, I draw a little unit circle just to remind myself. It's like a little visual that helps me process things. So sine of 30. 30 degrees is here. So that means I'm going to have the 1/2 and a square root of 3 over 2. Is sine the short side or the long side at 30 degrees? Is sine 1/2 or square root of 3 over 2? What is sine of 30 degrees? So look at your unit circle. Look at 30 degrees. Okay, 30 degrees. Right here. 30 degrees. I have two values that this unit circle helps me find. I have the height, 1/2, and I have the base here, which is square root of 3 over 2. Which one of these is sine?
1/2.
Okay, so sine of 30. So 1/2 equals sine of 30 degrees. What does this one equal? Cosine of 30. So that's how you use the unit circle. We are generally posed with a question like this. And yes, you could break out the calculator and do sine of 30 degrees as long as you're in degree mode. But these are common values that we see and that textbooks and tests create. And we have to know these because it makes your life easier. And in most cases, it is necessary to know these without a calculator. So back to this. Let's go through and figure these out. Sine of 30 was 1/2. Cosine of 30. Square root of 3 over 2. Let's move on to sine of 60. Look at your unit circle. Most of you are at a point where you should be looking at the unit circle because you don't know it well enough. Square root of 3 over 2. Cosine of 60? 1/2. Sine 45, cosine 45. These are the same. They are equal. 2 over 2. Square root of 2 over 2. And in a triangle, what we saw the other day was that tangent is opposite over hypotenuse. And in the triangles that we know, the opposite side of 30 would be what? Oh, I'm sorry. I'll edit that to make it look like I got it right. Opposite over adjacent, duh, and so that would be 1/2 over square root of 3 over 2. That's a 2. So let's simplify this. How do I simplify this? 1/2 times 2 over square root 3. 2's cancel out, and I'm left with 1 over square root 3. But that's no good. Square root of 3 over square root of 3 becomes square root of 3 over 3. Tangent of 60, so it's just flipped around. I have square root of 3 on top divided by 1/2, which is the same thing as square root of 3 over 2 times 2 over 1, the reciprocal of 1/2. 2's cancel out, you're left with square root of 3. And the hardest one, tangent of 45, is what?
1.
So it's 1, and if you don't remember why, it's because you have square root of 2 over 2 divided by square root of 2 over 2, and that would give you 1. So anyways, the unit circle helps us to find common trig values. It does not give us all the trig values, which is unfortunate, but that would take forever. So for example, if I had, let's say, sine of, let's do sine of 60, what would that be? Square root of 3 over 2. But if I asked for sine of, oh, if I asked for cosine of 65 degrees, what would that be? So the unit circle cannot help us with that. It can a little bit. It can at least help us estimate it. So let's look at this unit circle. I know, let's talk about the closest angle. What's the closest angle?
60.
I know 60. I know information about 60 degrees. So if 6 degrees is here, then I know that the x value here is 1/2. And then the y value is square root of 3 over 2. If I'm asking for a cosine, that means I need to be looking down here. 65 degrees would be just a smidgen past 60. So that means I have new x and y values. Which one do I care about if I'm asking for a cosine?
The x value
Look for the x value, which would be
less than half.
just a little bit less than half. So maybe .45 or something like that. It's got to be less than half, though. If you gave me an estimate and it was 0.75, you would be wrong. Okay? So again, common trig values. Not all trig values, but the common ones. And in general, math problems are written so that you can use these. Any questions?